Okay, hi, this is Erin O'Neill. I'm going to talk through my final quiz of the quarter, question number 5. So here we have an eagle that apparently has the same size eyeballs as humans, but they can see a rabbit from as far as 3 kilometers away, which is crazy. Rabbit doesn't stand a chance. So from this distance, is it possible for the eagle to resolve the separation between the tips of the rabbit's ears? So what I did first was using Raleigh's criteria, because it specifies the minimum separation between 2 light sources that can resolve into distinct objects. So given our angle and the amount of separation, and the diameter of the eye, given the wavelength and the diameter of the eye times 1.22, what is the smallest theta possible? So when I plug in, we know that the longest wavelength visible is 700 nanometers, and we know that the aperture or the diameter of the eye is something around 1.5 nanometers. And so plugging these numbers into that equation, we come out with the theta of, it is 5.693 times 10 to the negative 6 radians. So we'll call it 5.7 times 10 to the negative 6 radians. So that's its smallest possible option. And so when we then take the distance, the eagle is away from his prey, which is 3 kilometers, and then we take the distance between the rabbit's ears, which I just had to guess is like 15 centimeters. Who knows? Depends on how big this rabbit is. And so then you can find theta by the ratio of the change in x, like the distance between the ears over the r, the distance the eagle is from the ears of the rabbit. And so plugging this in, you get 5 times 10 to the negative 5 radians, which is even smaller than the theta up here was. So it's because of that, it's not possible. The ears are too close together that from that distance, they're just going to look like probably one per key ear.